The next panel is titled Strategies to Navigate the First Phase. And our panelists are going to be Ellen Blue, Jennifer Chayes, Sam Madden, and Sandy Pentland. And why don't we start with Ellen?
All right.
The first phase. Let's navigate it.
Fantastic. I will just talk a little bit about some of the things that we're doing at LinkedIn and some of the things that we've actually discovered. Kind of about the future of work. We've seen a lot of things already this morning about changing skills and unclear on automation versus augmentation and a bunch of other topics. The way we look at it at LinkedIn is we really have no idea what the future actually holds. In the end, the main thing that we're looking for is, can you build a responsive system which basically allows us to really, allows employers, educators, government, everybody, but most importantly individuals, to understand what is actually happening in the economy so that as jobs get augmented, as they get eliminated, people can figure out what those changes actually are and then act on them appropriately. So let me give you an example of something we're doing in Colorado. So in Colorado, we're attempting to bring jobs and education together in one place. So what we would like to do is for any individual, we want them to be able to walk up to see an interesting job for which they are not skilled and see associated directly with it a training program which that employer will use as a way to determine whether that person is right for that job or not. So it's bringing two things basically that have never been put together in the same place before together. And so as we look at the data in terms of what's happening in Denver, what we see is that right now, the very biggest demand in Denver is for something called medical coders. Do people know what medical coders are? So medical coders are people who basically look at the diagnoses being inserted into systems by physicians, and they give them a standardized code which then basically can link it up to a whole bunch of other diagnostic processes, to link it up to insurance and a bunch of other things. It's a very manual, by hand kind of process. But that is the biggest single need in terms of skill gaps in Denver right now, which is kind of wild because Denver is undertaking this gigantic growth path right now with all these technology jobs. And it also presents another interesting problem. Medical coders is one of those jobs that, as James pointed out a couple panels ago, is highly likely to be automated out of existence, right? So what do we do when we have a system which basically says, hey, you can go get trained to be a medical coder because there's lots of demand for it, but in 3 years that job might not exist? How does that actually work? So we don't know the answer to this question either. What we do know is that one of the major things which is going to be part of it is lifelong education. You're going to have to reskill over and over again in order to be able to keep up with changes as you go. And that goes for everybody, but it's certainly going to impact some people more than it's going to impact others. So let's say we had a system which was connected to lifelong education. Now the challenge is, how do we make sure people have time to go get educated? Because if you look at the people who basically would need to reskill coming out of medical coding, these people have, like all the rest of us, mortgages, families. They have maybe 1, maybe 2 jobs. They don't have a lot of time, and they don't have a lot of money to pay for that re-education. So what do we have to do? We have to figure out a way to get the employers more involved in education. We have to figure out a way to get government involved. Basically what I'm saying here is that we've got a system which is going to change heavily underfoot, but the only way we prevent it from getting out of control is to make sure that many, many people are participating in delivering a solution. So one of the big challenges, and I hope that what we can talk about on this panel, is we can talk about what are the solutions that are there, what are the things we think will work, and how can we get the right people participating in those solutions so that they'll actually function.
Okay. Oh.
Yes, you're next.
Yes. Okay, so do I have a clicker? I do. Thank you. Okay, so first of all, thank you for inviting me here. This is a great collection of people, and I'm seeing a lot of old friends here, so it's very, very nice for me. So my perspective on this, I'm a researcher and I run research labs, is what are we doing as we develop AI? that will allow us better to navigate this first phase and to go on to later phases. And what I'm gonna do, I like examples, they're very concrete, and you can start to think about all the philosophical and ethical issues on the basis of examples. I'm gonna give 2 examples where I feel we are really augmenting jobs that already exist, and then I will raise 1 concern in general and talk about some AI ways of maybe addressing that concern, and that has to do with fairness. So the first one is augmenting healthcare professionals. And this one is interesting because it is allowing them to do something that they haven't really been able to do in the past. And that is to help people with chronic diseases go through the behavioral changes they need to go through to manage those diseases better. And this is using reinforcement learning, which was the cherry on the top of Jan's cake. It's actually a really important cherry, okay? So what reinforcement learning allows you to do, and some of my researchers in Israel have done this, is to personalize and contextualize incentives for people with chronic diseases like diabetics. And this is something that healthcare professionals just, they don't have the time to do it, they wouldn't know how to do it. So for example, if you're a diabetic, especially if you're a diabetic, you should exercise regularly. Very, very important to long-term prognosis. If somebody said to me, oh, 90% of your cohort is exercising more than you, I'm a very competitive person, I would start to exercise more. Somebody else may say, oh my God, I'm already in the bottom 10%, I'm just giving up. And so this reinforcement learning tool, which is delivered over a mobile device, gives you what you need. It personalizes it and contextualizes it. Maybe it learns that in the morning you need a different incentive than in the evening. And it allows healthcare professionals to work with their patients to do things they haven't been able to do in the past. The second one is augmenting data scientists, and this is really, it's funny, because we think of data science as this cool new job, but in fact, the day-to-day existence of a lot of data scientists is very mundane. You get a data set, you have to pre-process it. You have to think through a lot of things simultaneously. As you're pre-processing, what model do I use? What machine learning model do I use? And then how do I set the parameters of this model? And you rely on your experience, but after a while it's like, wow, I kind of know what steps I'm gonna go through, ripe for automation. So one of our researchers, using probabilistic latent variable models, said, something that's this routine, you should be allowed to learn. You should be able to learn. And he did. He ran millions and millions of experiments, and now his system can do amazing things. In a few seconds, it can do better than most data scientists can do in a few weeks, okay? So you may say, oh my, here's this great new job. Are people gonna be out of work? No. There are really important things involving featurization. What features am I looking at that require the domain expert to interact with the data scientist? It's just, there usually isn't enough time for this. So there's gonna be a movement of data scientists towards these more creative kinds of endeavors. Now, my concern is that many of these AI systems are trying to optimize something. They're trying to optimize, revenue for an ad serve. They're trying to optimize many different things, okay? In the process, if you don't put fairness in there as something you want to optimize, then you are going to take the biases inherent in the humanly generated data, and you are going to make them worse instead of making them better. And here, I think, it's really important that we don't try later in the second or third phase to slap on fairness. We have to think about it as something we optimize starting now in everything we do. And I'm going to give you 2 quick examples of this. First is this thing called word-to-vec. It's embedding of all words in a 300-dimensional space. You see some analogies there that were completed by the standard word embedding. She is so lovely as he is to brilliant. I hope you guys think I'm more brilliant than lovely. I really, really do. Okay? Thank you. Anyway, this is not good. There are all these words that should have no gender bias in them that do in this space of things that are humanly generated. So we had researchers come in and collapse down anything that didn't in the dictionary have a gender bias to 0. Now, when this is used, for example, to broaden search results, if you know, I am trying to serve an ad to somebody who is advertising a computer programmer job, if they use this de-biased word embedding, they will not be serving it more to men than to women who are qualified. One other, fair classification. So, you know, we all know the horrible story, and this is not just Google, this happens all the time, of the image search on African American faces and confusing this with, you know, with gorillas and stuff. What was going on? What was going on is that we trained on data on white faces, okay? Not on enough black faces, not on enough Asian faces. So, you know, there are other examples of this that I'm very concerned about. What if I'm looking for a manager in a high-tech company? And I say, what are the characteristics of my current employees, and how are those correlated with what I knew about them before I hired them? So let's say, you know, having a computer science degree from one of these 20 universities is positively correlated with success. Having a gap in employment of a couple of years is negatively correlated with success. Well, what if I split men and women? And I looked again. It might be that having a gap of employment of a couple of years actually was positively correlated with success, because during those couple of years, the average woman was learning how to juggle 20 things, which all managers have to be able to do, okay? So you can look at the minority population, whatever it is, do the optimization there, and then come up with something which makes a lot more sense on the minority population. So what I'm saying here is that we have to think, as we are coming up with these tools, that we have to put fairness in from the start, because especially in things like connecting people with jobs, we want to make sure, but in everything, we want to make sure that our AI is doing better than humans, not worse than humans.
Hey everybody, I'm Sam. I'm on the faculty here at MIT. I'm going to talk a little bit about some work we've been doing where we think about how to build computer software systems that use artificial intelligence and machine learning. Before I do that, I just want to echo, I think, a lot of what Jennifer said. Those points all resonate with me, especially this fairness thing. I think if you look at some of what we've done in traditional industries, like look at the car insurance industry, for example. They do not allow you to price insurance based on certain factors. So in California, you can't price insurance based on where the car is garaged, because this is viewed as being possibly discriminatory. But I think there's a real challenge around these AI algorithms that they're so good at finding correlates and finding things that are predictive of something that has value in it, that something like that this kind of regulation is really no longer going to be effective. And I think that would be a really interesting thing for us to discuss. But what I actually want to talk to you about today is something that I think pertains to the future of work in a way that hasn't been mentioned as much, which is that I have a real concern that these technologies that are being developed are being sort of captured by a very small elite group of organizations and companies. And I think that a concern for the future of work for everybody, especially for the people who don't work for Google and Microsoft and LinkedIn and the other companies who can put this technology into effect, is how do we take these next generation technologies and kind of democratize them? How do we take them and get them out there so that everybody can benefit from these technologies instead of it being something that only these companies, elite companies who can pay engineers huge amounts of money and hire tons of PhD students that places like MIT produce? And so that's what we're trying to do in some of the research that we're doing here at MIT. We have a new initiative that we call Systems That Learn. And the idea is to think about how we take some of these machine learning technologies and put them into practice in a way that they can be adopted by everybody as opposed to only by these few elite groups. And why am I worried about this? Well, I think if you start looking around at some of the things that have gone wrong with artificial intelligence, you can find a lot of examples that to me are very disconcerting. And Jennifer gave a couple of, I think, good examples. There's some other examples that are out there. And I think as we talk about this navigating the first phase, I'm not exactly sure what navigating the first phase means, but one thing it might mean is how do we, as a society, move on to, a new world where, AI is, augmenting all these jobs, or where AI is doing all these incredible things that people are predicting it's doing. And I think a challenge, if we're going to ever get out of this first phase, is that we're going to have to convince ourselves that these algorithms really work and are really doing what they're supposed to be doing. So there's a couple of examples that I like to give that I think are illustrative of some of the pitfalls that come up. So one is an example, and sorry to my colleagues at Microsoft and LinkedIn, I guess you're now at Microsoft too, is this Microsoft Tay chatbot. So how many of you guys have know about Tay? Probably some of you have seen this. Okay, so Tay was a Twitter chatbot. So it was designed to act like a teenage girl, whatever that means. Okay, and it would respond to you when you tweeted at it, and it learned. So it acquired new conversational topics as you talk to it. And you can probably imagine what happens when you put such a thing on the internet. So these researchers at Microsoft did this. And people on the internet figured out how to make Tay into a very nasty chatbot. She said things like, Hitler did nothing wrong, and a lot of other things that are not fit for me to say, okay? I think this is a scary example because, I, as a sort of naive person, would assume that, a group at Microsoft that's putting a technology out there would be sophisticated enough to put it out there in a way that it wouldn't be subject to these kinds of pitfalls. And yet, here's this group, presumably of PhDs who are highly skilled in the art, who put this thing out there that had what I think was a rather embarrassing failure mode, okay? There are other examples of these learning algorithms having failure modes. So for example, there's a group at the University of Washington who's shown that you can put little black stickers on a stop sign in such a way that you can fool vision algorithms into thinking stop signs are speed limit signs that say 45 miles an hour. And a person looking at these stop signs would never be confused by them, but these researchers have figured out how to get into the guts of these algorithms and trick them in very specific ways so that they make these really rather disconcerting errors, okay? So I think one of the things we need to do is to figure out how we develop technology that helps people who are not expert users when they put these algorithms into practice to avoid some of these pitfalls, okay? And that's what we're trying to do in the Systems That Learn initiative. We're building software tools, for example, that explain what it is that these algorithms are learning. They give you examples that show you what the algorithm has learned or how to differentiate a prediction of why an algorithm is predicting one thing instead of another thing, so that you can avoid these, understand where these corner cases are, like, for example, that this stop sign is not really a speed limit sign. You can look at the internals of these algorithms and see where the boundaries are between stop signs and speed limit signs as far as the algorithm is concerned, and then test that against your own intuitive knowledge as to whether this algorithm is learning something that's what a person would learn. Because after all, if we're going to give these things to doctors, or if we're going to give these things to, have these things taking care of our elderly parents, or if we're going to trust these things to drive our cars, I don't think any person is going to want to use a technology that doesn't behave in a way that is consistent with their own sort of mental model of how, somebody should behave, something should behave as it interacts with humans. So that's what we're trying to do in this initiative, and we've got a lot of really cool technology that we're pushing out there. And I think the message for me is the algorithms are there. What's needed is all the supporting technology around the algorithms to make them exist in our world in a way that is sort of compatible with how humans think and behave. So I hope we can talk about that a little bit in the panel as well. Thanks very much.
Good. So my name's Alex Pentland, but everybody calls me Sandy. I'm faculty here. I'm going to use a cheat sheet. I'm the only one doing this. Amazing. So my point here is when we think about these things, I think we're doing it in the wrong frame of reference. The thing to be concerned about is not jobs, it's networks of production. A job by itself is this sort of static industrial age thing. It's like, well, you sit here and do this all day long. No, it's how that connects to all of the things in society that's where the value is produced. And if you look at the sorts of things that we see, and this is from 1980 up to today, you see that indeed routine tasks have been going away. This is not new. I think the newest thing is now it's hitting some of the professional classes like lawyers and people like that, and so that there's a lot of hubbub that wasn't there when it was getting rid of welders and people like that. And because people are really, really bad at logical STEM skills, that's why we have things like universities, we pay most attention to these analytical tasks, which are indeed growing. And it's the thing that we hear about most here. But actually what's growing most are tasks requiring social skills. And if you look at the income, the salaries being paid for these, the social skills are right up there with the machine learning skills. And that's probably surprising to the most people here until I tell you that the social skills are things like entrepreneurs, intrapreneurs, deal makers, management. Of course they get paid a lot, but what's interesting is that those are in increased demand because society is becoming more complicated. Those networks of value need to be managed in a very different way. So we did some work a couple of years ago that I think expresses a lot of this. This was in Nature Communications. So this is social network density, which is basically how many different types of people can you easily get in contact with? What's the space of opportunities that you can see in your daily life? And these are cities in Europe, all across Europe and all across the United States. And you can see as the density of opportunities goes up, the GDP per square kilometer goes up too, in a very nice linear fashion. This is most of the economy in the US and in Europe. And so what it's saying is that if you can find opportunities, if you can meet with people, then the more you can do that, the more money, the more productivity. Now you notice that all of these guys have the same internet, all of them have the same news resources, all of them have the same educational resources by and large. What's different is that sort of human connection is different. And I think that's the thing that you want to pay attention to here. So it's not replacing jobs. Jobs are this industrial age thing. You know, imagine the guy sitting there doing the same thing again and again. It's how do you add value to the network? And indeed, these are the things that I think are going to see augmentation in a very positive way. You're going to find deal makers, you're going to find all sorts of these connector people being augmented by AI. And it's not a question of employment, it just creates a lot more value and a lot more opportunity. It's a virtuous cycle. And it's worth remembering that something like Google, for instance, is an AI to connect people with what other people think. It's not an AI by itself. LinkedIn, Facebook are obviously connective technologies. Amazon is even a connective technology between small businesses, businesses of all sorts, and customers. It's not this mind that's replacing jobs. In my group, we spun out many companies that do this. We've helped call centers. We help people in call centers have better conversations by being emotionally intelligent. That's a company called Cogito. A company called Humanize helps break down silos in corporations. Ginger helps mental health professionals connect better with their patients. All of these are not replacing people, they're augmenting the social side. And I think that just produces this virtuous cycle. So the key insight that I'd like to leave with you is that if we get into this, as we get into this domain, this new age, what we need to think about is having our networks be much more fluid than they are today. Today, we think about org charts. We have all this regulation that limits how people can do work, how they can move around. Retirement funds, health funds are tied to those antiquated notion of jobs. It's incredibly stupid. We need to be much more fluid. And the insight I want to leave you with is that the networks you see in a company or in society are very much like the networks in deep learning. They're connecting these little neuron things, except that in corporations and in society, the neurons aren't little linear functions, they're people. What we do is we take the intelligence out of those networks by imposing frozen structure on it. The magic of AI today is this reinforcement learning. It's a credit assignment function, if you know what that means. We don't do that as much as we should in existing corporations. If we could have continual feedback and continual rewiring the way you do in deep learning, we could make organizations and society that was dramatically more intelligent. If you want a buzz phrase, presumably everyone knows what the word Kaizen means. It's the Toyota continuous improvement by people observing things about their job and suggesting changes. So think about having Kaizen all the way up in the management levels as well as on the shop floor. And I think that's what we need to do, is bring that sort of reinforcement learning to the social domain, to the networks of production. Thank you.
Thank you. That's great. Before we get into this, it is hard to walk and chew gum. So if there's trying to follow the Twitter feed while I'm doing this is challenging. So if you do have a question you'd like me to ask the panel, if you could precede it with a couple question marks, I might be able to find it. I might not, but I'll give it a try. And thank you, Sam, for explaining what the panel was. Let's stipulate that the first phase is an AI full world, and by those standards, we're there. We're getting, I mean, AI is touching almost all of us. Alan, you raised one thing that really intrigued me. So how get the government involved? How do you propose to drag the government into this, particularly this government at this time?
Okay, that's an extra hard question. It's a great question, and I think the answer is different at every different level. It's different at the federal level. It's different at the state level. There are some governments that we work with which are extremely proactive. If you work with Singapore, if you work with India, they are just dying to put these things to use in their economies. And in some places, I think you're going to find places where industry or education actually need to lead and kind of drag government kicking and screaming into the world. For instance, if, like we had at LinkedIn for a long time, you had the ability to see how efficacious a particular education program was, because we're able to rank training programs according to how successful their graduates actually are. If you actually were able to do that, that might be a pattern by which the government could, I mean, not necessarily ours, but a pattern like that by which the government could say, you know, we're going to set policy that we're going to reward the programs that really work. Because now we know which programs actually work. So maybe there's a way that industry or educators can lead.
Yeah, Sandy, do you have that?
So I had a little private meeting with the leadership of the DNC and said, okay, now what are you going to do? And one of the questions is, what can we do with today's government? And there's one place where there's real alignment, and that's around helping small businesses, and particularly local small businesses. Everybody is enthusiastic about that, regardless of the side of the aisle. So things about that, and things particularly if you think about AI to help small businesses, to be able to automate the regulation, the processes, and things like that, you would get enormous support from everybody about that.
Is there a suite of AI stuff that could be actually given to small businesses at that time? Is it organizing itself that way?
I think there are things. I mean, I mentioned this tool that we have for, that one of my researchers using probabilistic latent variable models came up with. But what that does is if you have data scientists, it allows them to do more sophisticated things. But if you don't have data scientists, you can take your data from your small business and you can actually start to have predictions, serious predictions about what you should be carrying in your shop or how you should be allocating your resources in various ways. So I think a lot of what is going on in AI today is about democratizing AI and taking it to the level where a small business really could benefit from this.
You think about something like, just like a simple pattern, detection thing where I can input all the things that I've sold, and as you said, it'll tell me what is likely to sell next, or what's likely to be popular in this season, or what are looking across demographics, what are people buying, and those things are all things that you could imagine pretty small businesses would be interested in and could value from. And I think you could imagine building versions of these that don't require you to actually understand the details of the algorithms to put them into practice.
Right. I mean, the one I was talking about, you just spit in your, it does the pre-processing,
Yeah.
it does everything. And so we need more things like this, but I think AI is going to trickle down into all parts of the economy.
So one of my sponsors is Intuit, which is like the number 5 of the big 4, right? and most small businesses have AI to manage their books, their labor, their this, their that, but it's not really connected yet in some of these ways. And so I think that there's a real appetite for it, and there's probably a real opportunity because most of the processes are already digital, so the data is there.
And honestly, if the small businesses can use these kinds of AI tools to increase their business, they can hire more people.
They are
it's
the
not
number
like
one
they
source
have
of
a lot
jobs.
of analysts or data scientists or but if they start to sell more, or if they start to get more requests for their services, then that is job creation.
They're by far the dominant job provider in our economy, right?
Yeah.
Ellen, when you talked about medical coders, or this new class of, I guess I think of them as ephemeral jobs, the first thing, I mean, I just have to commend Charlie Stross, a science fiction writer, to the audience, who wrote a short story called Acceleranda, which is the most descriptive science fiction story that I've seen recently that sort of captures the world that you were hinting at. I mean, how unique is that kind of transitional job that you would have a good vision? Is that unusual, or many of them?
I don't know. That's a bad answer, but what we have tried in many different ways. I was talking to James about this. We've tried in many ways to figure out what's actually coming, and it's very hard to predict. That's why the systems that we put in place in order to do this have to be learning systems. They have to be systems which respond well to the changes as they occur, rather than trying to predict what those are until we're actually able to accurately predict them.
And is your assertion that medical coder is fairly short-lived? I mean, what kind of assumptions are you making about the progress of AI technology? Maybe it'll last a lot longer than, no. It's all.
I don't think so. I mean, so you're talking about ICD-9, ICD-10 codes for insurance billing. There is tremendous reason. There are huge incentives to go in and use machine learning in the medical domain.
Yes.
To take your electronic medical records and start to learn from them, both the structured data like the tests and the unstructured data like the doctor's notes and the images, because it will lead to much better outcome for the patients, greater efficiency, lower cost. So the insurance companies that are the source of these jobs, of these, ICD-9, ICD-10, have huge incentive to mechanize this in ways that also improve health. But there's Uber, right? Uber is another last mile company. You don't even have to get as esoteric as ICD-9 codes. You can say, okay, well, Uber didn't exist and now Uber exists because we got the infrastructure on the back to connect drivers to people. And so now that new class of jobs exists, and we all know that those are not going to be around for that long because we're going to have driverless cars. But I think there will always be, and I've got two researchers, Mary Gray and Sid Sori, who are writing a book on this. One is a social scientist and one is a machine learner. They start out interviewing dozens of or hundreds of people in India, who do mechanical Turk and stuff, and they said there's always a last mile because we have new technologies like the back end of Uber or being able to do this billing in a certain way where the AI can't yet do the last piece of it, can't yet drive a car. But there'll always be that.
So
Sandy.
one of the things that I'm concerned about, and is in some ways a precondition for a healthy future, is there has to be a lot more data sharing and data transparency. So currently, you see these castles, these sort of incredible concentrations of data in very few hands. That makes it very hard for startups, it makes it hard for SMEs, it makes it hard for government or citizens to know what's happening. So there has to be something that allows access to data, use of data much more generally so that you can get innovation and so that citizens and government can be informed. And currently the major sort of barriers to that are, of course, proprietary ownership. Privacy laws are outdated. Like for instance, during the Ebola outbreak, companies couldn't contribute data that would have been critical, was critical, because of privacy laws. There have to be some more sophistication there. And I think that one of the things to remember is AIs are only as good as the data that they have. And if you choke off the data, you choke off the AI. And if you're concerned about fairness, you have to know what data went in to be able to evaluate whether the decisions were good. So that sort of transparency, tradability, et cetera, are absolutely the substrate for doing this right.
Sam, could you talk a little bit more about your notion of the concentration of AI technologies and what the consequences are?
Well, I think it's very much along the lines of what Sandy's talking about. You get the data, you get the competency in the algorithms, you get the most effective algorithms concentrated in a few places, and the question is that then allows the people who have that concentration to further their own interests. And as much as like Google's done some great things with putting technology out there that other people are adopting, Microsoft too. There are of course on one hand they want the technology to get out there because it creates buzz for them. But on the other hand, in the areas where they dominate, you look at Google and advertising. I guarantee you they're doing things with AI in advertising that goes way beyond what anybody else is going to do. And so it creates a barrier to entry. And I think it's really important that we, as a society, think about how we want that data to be used, that we ask these questions about what data are we going to allow people to collect, that we have some transparency in what data is being used and how it's being used so that you can avoid these possible issues around discriminatory practices, or so that, imagine, for example, a day in which LinkedIn, which maybe you're doing already, recommends jobs to me based on, some automated algorithm that looks at my profile, right? Like, if that is, if that,
their business model.
if it's doing that, right, then, how do you have some confidence that it's not doing it in some unfair or discriminatory way? I think that's why we need this transparency, why we need to have tools that explain what something is predicting to us, and why we, I think, it sort of worries me that this technology is really being concentrated in these few places and where there's not much transparency into how the technology is being used.
There are domains outside of the private sector where I think we're going to have some kind of incentives for the sharing of data. But Medicare data, okay, the government pays for the collection of that data. And that data could be used in ways that really improve everyone's health. So there are certain domains where I think we can start to try to find ways to share data, let people opt into sharing data, where we haven't yet done this, where it's where we've all paid for the collection of that data.
Yeah. We have a question from Kevin Dooley. Will high school education become more relevant than college education with acceleration in AI and learning?
So I just want to echo one of the points you were making about the value of the soft skill. So one thing we've seen at LinkedIn is that the technical skills change more and more frequently. We have a new list of top technical skills all the time as new technical things come online. The thing which has remained extremely constant and more important, and more employers talk about it, is this notion of soft skills. So one of the interesting things about a focus on STEM and a focus on like getting people technical skills and everything is that if that is done at the expense of the ability for human beings able to do human things with each other, that's a really bad trade-off. So I think one of the real challenges, and this comes from that kind of the idea I was trying to get across, which is we might be able to build a responsive system, fantastic. We might be able to get some educators at the college level involved, fantastic. Maybe some employers, fantastic. But if in fact what we're talking about is the development of soft skills, we're talking about people being prepared for a workforce where they have to be very human and very able to collaborate all the time, those things happen in high school. They happen in the experiences you start at the age of 5 or 6, that ability to work with other people. So unfortunately, the change, the level of change required to prepare for the future requires us to rethink education all the way down to the kindergarten level. And that's very challenging. Not because we don't know how to do it. We do. There are ways of teaching 5-year-olds how to be great collaborators, and it affects the rest of their lives. But that's not the usual education that people get, at least not in this country.
One of the things I think is actually really sort of shocking about modern technology, exactly playing on these lines, is I don't know if you guys have seen these studies about how teenagers are spending their time, but there was a recent article about, teenagers are actually interacting with each other less. They're sitting in their rooms on their phones instead of going out and, going to parties, and it's manifests itself in things like teenage pregnancy rates, which you might think, okay, it's good, teen pregnancy is down, but actually what this is that kids are like becoming sexually active when they're older. They're interacting less with their peers. They're going to fewer parties. They're doing fewer drugs. It's these really kind of weird, interesting changes in social dynamics. And you can laugh, you say this is all good. And at one level it is good, but it's also, I think it suggests that this technology that we developed is actually having kind of weird effects on our social interactions. I think what the point you made is a really fascinating one.
So to answer the person's question there, or try to answer a little bit. So one of the things that I've seen here is there are some radically different educational programs. And it's just by some accident, they tend to be run by people who escaped Russia in sort of 1990 or so. Just very different attitudes towards education. And I see a crop of kids in middle school and high school that are doing stuff that is advanced graduate research. Right? So it's possible to teach kids, to let them loose in ways that are stunning. I mean, just an order of magnitude better. These are bright kids, but they're not inhuman. And so I think this challenge of doing it all the way down, I think we could do an order of magnitude better job. It's going to take some experimentation, but boy, it may be possible.
We're running out of time. I have one final question for Sandy, because when you put up that chart about what I took as urbanism and interaction, I wanted you to overlay red state, blue state politics on top of them. And do you have any insight into how that affects our politics today?
So what's, oh yeah, we have quite a bit about that. So the chart about money, that's not a red state, blue state, and because a lot of the things that drive that are transportation infrastructure and other sort of physical infrastructure, which is pretty uniform. But if you look at almost any sort of conversational thing, it's driven by the segregation that has happened in this country and other countries over the last 30 years. Over the last 30 years, we've had somewhere between, it depends how you measure, but somewhere between 30 and 50% greater segregation by income than we had, say, 30 years ago. And if you don't actually interact with people, you don't share the conversation, the views, you develop a separate story. And it's that segregation that I think drives the political dysfunction here and elsewhere. And the little test to ask yourself is, how many people do you know who own the best-selling car in America, which is a pickup truck? And in my environment, almost nobody knows anybody with a pickup truck, even though it's the best-selling thing. That tells you that we don't know the people in it's not red, blue states, it's this zip code versus that zip code, right? It's that close, but we don't talk.
We're out of time. Please join me in thanking our panel. And I think, thank you very much.